Welcome. In the previous section, an analysis was made leading to the requirements on the powertrain based on the forces acting on a vehicle. In this section, we will go from the wheels and the force requirements acting on these through the driveline, that is, differential, gearbox and clutch, to the engine and the fuel tank. In a later section, we will do the same for a battery electric vehicle, but then the final power unit will be an electric machine with a battery. The powertrain considered here we will call the conventional powertrain, just because it is the common one, for now. So, first let us take a look at the conventional powertrain, that is, the internal combustion engine together with the transmission. The figure shows a schematic version of a normal powertrain layout with the fuel tank, the engine, the clutch, the gearbox, the drive shaft, the differential and final gear, and then the wheels. The clutch is a device which makes it possible to connect or disconnect the engine and the gearbox. When connected, the gearbox together with the final gear transforms the engine speed into the speed you want for your wheels. The differential is a device that permits the drive shafts going from the differential to the wheels to rotate with different speeds. The engine can only operate within certain boundaries. For instance, there is a minimum and a maximum engine speed, often given as revolutions per minute, RPM. So, if the wheels are to rotate in accordance to a certain vehicle speed, gears are needed to match the rotational speed of the wheels to the rotational speed of the engine crankshaft. When we model this powertrain in QSS, it will look like this. We then start with the driving cycle and the vehicle model, where the force and speed demand are calculated. Then we get the wheel model and all the powertrain parts, where, for instance, the input to the transmission, which includes both the gearbox and the final gear, is torque and speed demanded by the wheel, and out is torque and speed wanted by the engine. Also, out from the engine is the fuel input, the fuel power needed to produce work. The following lectures will go through the powertrain parts, give a rough overview how they work, and a description of important properties and parameters used to describe the parts. There will also be descriptions of the different parts in QSS and how they are put together into the complete powertrain. Finally, there will be some examples where a QSS model of a car is used to analyze the influence of car properties and driving conditions on fuel consumption.